Well, Joey, in this video we're going to model a tie building block. We'll also talk a little bit about parametric design and what it means. Alright, so we're going to create a new document. Again, isometric part. Ordered. And I'm just going to hit save. Got a part name, document number, revision ID, and a title. Okay, so look, we can see the views here. Here is I'll just turn on the planes, and there's the top plane there. So we're just going to do a basic 1x1 block. We're going to start off by starting the extrude command. So I click on extrude. The extrude workflow opens, and the first part of the workflow is create a sketch, create from Coincident Plane. And we can also see in the prompt bar, our little prompt here, click on a plane or face or reference plane. So I can click on the top plane here, and now we're still in the extrude command, but we have entered into the sketch environment, and you can tell that by the commands shown along the ribbon and the close sketch command here and here. Solid Edge by default has brought us into the line command. Instead of the line command, we're going to use the rectangle command. And we go up here and choose rectangle by center. Generally, it's a good idea to try to model features around the origin plane. So generally, as a rule of thumb, it just makes life easier for you. So we can do that. And if I hover over the origin here, and you can see the origin highlighted by the orange dot, I'm just going to click, and now that's the center point of our rectangle. I'm not going to worry too much about the actual dimensions. I'm just going to click anywhere. And that's the basis for our sketch. Now we're going to use the smart dimension. I click on that, and we're going to lock in the different values. So that is going to be 7.8 millimeters, 7.8. And because it's a red dimension, it's a driving dimension. And I'm going to do the same here. And 7.8. Okay, that's the basic outline of our part. So what we can do now is just click the exit sketch icon here. So now the sketch is closed. We've moved on from sketch, draw profile, we're moved on to the extent. In previous lessons we've done symmetrical extrudes. This time let's do a one-sided extent. So we can do it above the part. The distance box is selected by default, so I can just type in the amount. I'm going to type in 9.6 and hit enter. And step is 0. I'm going to hit enter again. Now it's actually waiting for which side of the part, so we can go down from the top plane or up. I'm just going to choose up. Both ways are okay. And that is the basic part. You can see a little bit of differences in color there. That's actually where the different reference planes intersect the part. So if you're thinking there's something missing, you can see a kind of a darker grey area and lighter grey areas. That's because there's a plane coming in here and a plane coming in here, and everything's a little bit lighter behind the planes. So I can just turn off that display, and now the whole part looks uniform. So we don't need to worry too much about that. It's a good idea to try and save things regularly. So I'm going to hit save. And next we could create the peg at the top of the block. So let's do that. So that'll be another extrude. And again, we're going to use coincident plane. This time we're not going to use the top plane. Let's use the top face of the part. Click there, and now we've automatically gone into the sketch view. So we're in the sketch environment, and Solid Edge has started the line command. We don't want the line command. We're making a circular kind of a peg. So I'm going to click the circle by center point command. Go back out here. And now, actually, because we have created this part symmetrically around the coordinate system, I know if I place the center of the circle on the origin of the coordinate system, it will be located on the middle of the top face of the block. So I just hovered over the origin to infer that relationship and clicked. And now I click away. So we haven't locked in our diameter. So I'm going to use the Smart Dimension, click on the circle, and I'm going to type in 4.8 millimeters for the diameter. Auto scale automatically scales a 2D or 3D. That really doesn't matter because there's only one part in the sketch. That really doesn't matter. We can look at that another time. So that's all we really need for that. You can see that the circle has turned black because we have relationship colors enabled. Our sketch is fully constrained because we have related it to the origin. Even though the origin is down here, because we're drawing on the sketch plane, everything happens on that plane. So even though it's vertically away from it, it's the position of the origin when looking at the sketch plane is what is the relationship that's actually tied in. So now we can exit that sketch. And again, Solid Edge is looking for a distance to extrude. If we go down, it's cutting a hole into the part. If we go up, it's adding material. So I'm just going to put in 1.7 millimeters and hit enter. And again, it's looking for a step. We can go down 1.7 or up 1.7. I just move the mouse in the up direction and click that side. And now Solid Edge is looking for a name of the feature. I'm happy with the default name, and I can just click finish. And that's pretty good. So I'm going to hit save again. We're kind of almost there. There are different ways we could do this. Since this is a kind of a beginner's video, we're going to do it maybe the beginner's way. And it may not be the most efficient way of doing it, but it's probably good practice for starting out. So we just want to cut into the block now. Alright, so let's do another extrude. So we want to cut out the hole in the bottom of the part. There's the top, there's the bottom. So if we go up, you can choose Extrude again. And sketch, create from Coincident Plane. So we're going to sketch on the bottom of the part, the hole we want to cut out. So Solid Edge has brought us in at 90 degrees to our sketch plane. And you can see from the close sketch icon and the close sketch icon here, and the different sketch commands available to us. We've been brought into the sketch environment, still in the extrude command, but in the sketch environment at this stage. So we can choose rectangle by center and define the cutout using that, which is perfectly fine. Or we can choose the project to sketch command. Let's try that. And I'm just going to, let's have a look first at what the default options for that. I'm just going to select OK. And if I click, we're on single face mode. And if I click on the face, we can see that these green lines would be created in a sketch to create a sketch profile. The outline of the face we projected to the sketch plane isn't directly very useful to us. It would be a lot more useful to offset a distance from these lines. So we can click on the Options button within Project to Sketch and enable the Project with Offset option. Click the bottom face of the part. We can enter an offset distance for the projected outline of the face using the wall thickness we want the part to have. If I move the cursor inside the part, an orange preview of the offset outline of the projected face is shown inside the part face. If I move the cursor to the other side of this orange arrow, the offset outline flips to 1.6mm outside the part face. I move the cursor back to the other side of the orange arrow and click. This creates a fully defined sketch with just one single dimension, the 1.6mm offset distance. So I can click on this Close Sketch command. And now we've moved on to the Extent part of the Extrude command. We have different options here. The Extrude Through All probably isn't our friend because it'll cut right through the part. Extrude Through Next won't be much nicer to us. So if we look at that, that's pretty ugly. Extrude From to Extent. Let's take a look at that. So the From is pretty straightforward. We can extrude from the bottom face. We're going to leave the offset at 0mm. And it can be easy to get a little bit lost here, but we can see up here in our prompt bar, select to surface or right click to extrude to profile plane. So we can select the to surface, but maybe before that, let's select the offset. So I'm going to choose 1.6 and hit tab. And now if I choose the to surface, we can go up, offset 1.6mm up, which would cut more further into the part, or down. So I'm going to choose down. You do see the preview here of how it would cut, but I'm hoping this offset will help us out. So I'm going to go down 1.6mm and click. And now you see that the material, the offset helped us out there. And it has added 1.6mm of material from the top to the bottom. So now we're just looking at the finish, kind of a preview of the finished part. Give it a name, which I'm happy with, or just click Finish. I suppose we could take a look if you have any doubts about is it constructed correctly. Let's maybe take a measure. So we can go to the Inspect tab, up to the ribbon, and we can choose Measure Normal Distance. And we can look at the prompt bar again, click on a line or plane to measure from. So I'm going to measure this face in here. So that's the face that we just cut out. And if we go back to our prompt bar, click on a key point to measure to. So this is measuring the normal distance, the distance at 90 degrees. So it doesn't really matter. Any point on the face of this part, it will give us the normal distance, the 90-degree distance to that. I can select the center of this circle here. And let's take a look here, 1.60mm. So that's the thickness of the part. To the bottom of that circle, the circle was probably a little bit confusing, so let's just take a look at it from the side. And now you can see, so the face is previewed in that green line there, and the center of the circle, it's the circle at the bottom of this cylinder, not at the top, is in line with the top face. That's 1.6mm, so that's absolutely perfect. So we got that. Gonna click Save. And next we can cut out just a little hole on the top into the part. Let's do that. So I'm going to click Home, and we're going to choose Extrude again. And this time the sketch plane is going to be the end face that we just selected. So let me just, so it's this face inside the part here. And again, it's brought us into the sketch environment and started the line command. We don't want the line command, So we can do circle by center point, and because we've created the part symmetrically about the origin, we can use the origin of the part as the center of the circle. If we hadn't done that, we could do it a different way. So let's just do it the other way anyways. So we're going to use project to sketch again. This time, I'm not going to project with an offset, so let's just click OK. And as well, let's use create as construction. So we're still in project to sketch, and we're drawing lines now as construction lines. So let's zoom out, rotate the part around with the middle mouse button, and if I click on the top peg of the part and click on that, that gets projected down to our sketch plane. And now I can accept that. And now we see this kind of construction line there. And now let's create a circle. And I'm just going to click kind of anywhere. Oh. And now actually I don't want to create a construction line now because we want to actually do something with this line. So I'm going to click again on create a construction. Now we have a solid line. This is for actually extrusions and making things. So now we have one construction circle, which is fully defined. It's related to the top face of the peg. And we have this blue circle here, which isn't constrained at all. Only that it's on that plane. So let's, for starters, add a constraint. So we're going to make it concentric. So I select this circle and this construction circle. Now they're both concentric. Because this one is fully defined, it's black, that kind of locks this one in position. It would have been fine if we had chosen the origin as well. That would have had the same effect. And all we really need to do now is to create a dimension for that circle. So I'm going to choose a smart dimension. And I don't actually know in this case what the dimension of that circle is. But I do know it's 1.6 millimeters less than this circle. So we can just let Solid Edge do the heavy lifting for us. So we have the smart dimension open, and I'm going to go more options, go down here, and we have this option here, tangent. So I'm going to select that. Instead of, I'll just turn it off for starters. So if I was to make a dimension from a circle, see, first of all, it's tries to do a diameter dimension, that's the default. But if I'm relating it to something else, like a line, it goes from the center of the circle to the line. Or another circle, it'll go from the center of the circle to the other circle. Because those two circles have the same center, it's a 0 dimension. So we don't want the dimension between the centers of the circle. We want it kind of between the actual tangents of the circle. So if there was a tangent line drawn here and a parallel tangent line drawn here, we'd want the distance between the two parallel lines. So that's what we're going to do. We're going to choose the tangent, select either circle and the other one. And now we have the tangent distance here. So I'm going to click that, type 1.6, hit enter, and now we have a fully constrained circle. So I'm going to click on the close sketch command, and now we have the extent. So we still have the automatic option, add or cut. So I'm just going to choose cut. We could leave it at automatic. It's not really a deal breaker. And we can do the same thing again here. I'm going to go down here and choose from to extent. And we're going to choose this face as the from, leave the offset at 0. So that's okay. And now it's the prompt bar is telling us to select the 2 surface. So this time the 2 surface I'm going to select is the top of the hole. Well, you see it's previewing that it's going to cut right through the hole. We don't want that. So maybe let's give that an offset first to make life easy on ourselves. So I'm going to type 1.6 and hit tab. And now I'm going to choose the top surface. It's still giving us that preview, but I have a little bit more faith that we've selected an offset. So I'm going to select it. And now we see this arrow here. And we see in the prompt bar, select the side for the offset. So we don't want it to go, if we choose the offset that side, it will be 1.6 millimeters above the part, it'll cut right through, or down, it'll be 1.6 below and give us a thickness. There we go. So now we can give the feature a name or click finish. And it enters the extrude command again. I'm just going to click cancel. And if we wanted to, if you really don't trust me, we can check that again. 3D measure. I'm going to choose the cut face in here and the top face of the part here, and that's 1.6 millimeters from the top. And you can see there the feature. The top face of the cutout. It's actually a little bit, so let me just select the cylinder so we can take a look at it from the side. Yeah, so it's from the top face here to the top of the part is 1.6 millimeters, so it's a little bit above the other face we saw. Alright, so there's our part. One thing I said to you was we would talk a little bit about parametric design, and if you looked at the first 2 videos, they were kind of a gentle introduction to parametric design in themselves. So parametric design sounds kind of like a fancy term. So parametric design is where parameters or variables along with relationships are used to define parts. So what does that actually mean? Well, you saw the relationships we created in the sketches to define this part. That's part of it. Also, the parameters, that's really just the dimensions that we use to define the part. The idea is that you can change parameters to change the design. So we effectively did this earlier. Let's do this again for this part. Again, we're going to do a save as. If we wanted to do maybe one of those 1/3 height blocks, we can save this part as, give it a file name, a document number, and a title, and click save. And we can look at the different parameters of the part. So the parameters of the part, they're the variables, the values that define the part. We have this dimension here is 7.8 millimeters. This dimension is 7.8 millimeters. Extruded protrusion, 9.6 millimeters, that's the height. So if I wanted, in this variable table, I could change all of those values, each of those values, to change the shape of the part, change the size of the part. So yeah, they're the parameters or variables that define the part. And changing them in the variable table, you can also get a little bit fancier and create equations based on conditional logic to change your designs. But for now, we'll just keep it simple, and that's the basics of parametric design. So I can close this table. And another way of changing the part is by actually going to the actual different features on the Pathfinder. So here's our cutout we made. Here's our first cutout. There's our second protrusion and our first protrusion. So if we wanted to make this a third the height of the normal block, we can click on the first protrusion, either in the pathfinder or on the part itself. So if we wanted to change the parameters, change this to a 1/3 height block, we could click on the protrusion in the pathfinder, click on edit definition. There's also this dynamic edit. So we could go into edit definition. I think we did that in the last video. Also, we could just click dynamic edit. So I click that. And now we see the parameters or variables that define the part. And if we want to keep the actual size of the part the same, the width and the length, and just change the height, I can click on this dimension and change that from 9.6 millimeters to 3.2 millimeters and hit enter. And now we see our part has updated. The new part has basically been defined from the old part, and that's kind of the basics of parametric design. So we still have the prompt bar here saying click on elements to edit. So it's waiting for us to change other dimensions. We don't actually need to change any other dimensions for this part. So I can just hit save and just the select button, and we can kind of go about our business. So in our next video, we're going to take this a little bit further. We're going to look at parametric design in a little bit more detail, and we're going to use parametric design to create different types of blocks. We'll also pattern features to make life a little bit easier for ourselves. I hope you found that useful. Okay, that's it. Thank you.